Hey guys, welcome back. Today we are going to talk about matrices. So a matrix is an array of data set into rows and columns like this. And the rows are horizontal. In this case there are 3 rows. Columns are vertical. There are 2 columns. Okay, so this matrix right here, we're going to write its dimensions in terms of rows by columns. There are 2 rows and 3 columns. That is a 2 by 3 matrix. So here horizontally we've got 4 rows and vertically 2 columns. This is a 4 by 2 matrix. So that's just what a matrix is, or what it looks like. We're going to talk now about how to find values of a matrix and then how to add and subtract matrices. So matrices are considered equal if they have the same dimensions and if they have the same corresponding elements. Same dimensions, same corresponding elements. Now these 2 matrices here are considered equal because there's an equal sign. That means they have the same dimensions. 2 rows, 1 column, 2 rows, 1 column. And they have the same corresponding elements, which means that y is equal to 3x minus 5. And that x is equal to 2y. And we can find values for these elements in the matrices by solving this system of equations. So if x equals 2y, then this x right here equals 2y. So we can substitute y equals 3 times, and then that x becomes 2y minus 5. Okay, so y equals 6y minus 5. And I can swap places with the y and that negative 5, and I get positive 5, and 6y minus y equals 5y. And then divide both sides by 5, and I find that y equals 1. Okay, so this element right here has a value of 1. This one also has a value of 1, but I need to find what x equals. Okay, I can plug that 1 right here. X equals 2 times... and that y I'm going to substitute in a 1, so x equals 2. And if I plug that in here, 3 times 2 minus 5, that is 1. So this is 2, and 2 times the value of y, 2 times 1, is also 2. So the corresponding elements are indeed equal with those values of x and y. Okay? Here is a 1 by 2 matrix and another 1 by 2 matrix. Corresponding elements are equal because it says they're equal. 23 equals 3x plus 2y, and 22 equals 5x plus y. Okay, there's multiple ways to solve this. I could use substitution, I could use elimination. Maybe if I multiply this one by negative 2, I would get negative 44 equals negative 10x minus 2y, and I can combine those two. Okay, so 23 minus 44 is negative 21. 3x minus 10x is negative 7x, and 2y minus 2y, that cancels. So I can divide both sides by negative 7 and find that x equals 3. Okay, then I can substitute that into either equation. I think I'm going to use the bottom one here. 22 equals 5x, which is 5 times 3, plus y. So that's 15 plus y. And I'll subtract that over to the left, and I'll get 7 equals y. And the last thing we're going to do here is adding and subtracting matrices. In order to add or subtract matrices, they must have the same dimensions. Otherwise, it is not possible. And in order to add matrices, you just add corresponding elements. 5 and 4 makes 9. 2 and 6 is 8. 7 and 8 is 15. So there's my top row of elements. My bottom row, 1 and 5 is 6. 3 and 1 is 4. And then 9 and 3 is 12. And that is my resulting matrix. Okay, then I've got 4 plus negative 3, and that is 1. 3 plus negative 4 is negative 1. And 2 plus negative 5 is negative 3. 6 plus 4 is 10. 7 plus 0 is 7. 8 plus 1 is 9. So that is the sum of the two matrices. Subtracting is very similar. I'm just going to subtract corresponding elements. 6 minus 4 is 2. 5 minus 7 is negative 2. 2 minus 5 is negative 3. And 3 minus 2 is 1. And last, 4 minus 0 is 4. 3 minus 4 is negative 1. 2 minus 10 is negative 8. And 1 minus negative 15 is 16.
We'll go ahead and finish up this lesson with some practice on systems of equations. We really want to keep this skill sharp, so here we go. So here I've got x equals. So I'm going to go ahead and take what x equals and substitute it right there. So I've got 3 times 10y minus 1 plus 5y equals 11. And I will distribute the 3. 30y minus 3 plus 5y equals 11. Okay, so I'm going to move that 3 over, and I'm going to combine like terms. So I've got 35y equals 14, which means that y is 14 over 35. 7 goes into both of those, so y is going to simplify to 2/5. Now I want to substitute that into one of the two original equations, and I think the top one is going to be the easier way to go. So I've got 10 times 2/5 minus 1 equals x. Okay, now 10 divided by 5 is 2, times that 2 is 4, so I've got 4 minus 1 is x. So x is 3. So the intersection of these two lines is at 3/2. Number 2, I think I actually want to do substitution on this one as well. So I'm going to take this equation and solve for y, and the way I'm going to do that is just move that to the right, move that to the left, and I get 3x minus 12 equals y. Okay, so now I've got y by itself, and I'm going to substitute that into the only other place that I have a y, and that is right here. Okay, so I've got 2 times 3x minus 12 minus 21z equals negative 22. So that's 6x minus 24 minus 21z equals negative 22. And I'll go ahead and move that over to the right side. So I've got 6x minus 21z equals 2. Okay, now I have an xz equation here. I have an xz equation here. I can eliminate the x's if I take this equation right here and multiply by negative 2. So I've got negative 12x plus 42z equals negative 4. And then I'm going to bring this down right under it. 12x plus 7z equals 4. Okay, so these cancel, and I get 49z equals 0. And 0 divided by 49 is 0. So I've got my value of z. Okay, once you get that first value from there, it gets a little bit easier. So I can take this value of z and plug it in anywhere up here that I've got a z. So let's put that right here. So I've got 2y minus 21 times 0 equals negative 22. Minus 21 times 0, that's just minus 0. So I've got 2y equals negative 22, and I can divide and get y is negative 11. I'll go ahead and put that 0 in here for z as well. So I've got 12x plus 7 times 0 equals 4. 7 times 0 is 0. So I've got 4 divided by 12. X equals 4 twelfths. And 4 goes into 4 and 12, 1 and 3 times, so x is 1/3. So my intersection is at 1/3, negative 11, 0. Okay, now it's always a good idea to plug your answers in, even on a 2 by 2, but a 3 by 3, there's just a lot more opportunities for mistakes. So I'll plug in my numbers here. 3 times 1/3 is 1. Okay, and then 1 minus negative 11 is 1 plus 11, which is 12. So my numbers work there. 12 times 1/3 is 4, plus 7 times 0, which is 0. 4 plus 0 is 4, so it worked there as well. Okay, and then I've got 2 times negative 11, so negative 22, minus 0 equals negative 22. So my numbers checked out in all 3 equations. Okay, on to number 3. So on number 3, I've got an xy, then an xyz, and another xyz. On this one, I'm not so sure substitution is the way to go, but I've got an xy here, so if I could cancel out z's between these two, I'll have another xy equation. So let's try that. We'll multiply this equation here by negative 2, and when I do that, I'll have a positive 2z to cancel out this negative 2z. So I have negative 2x plus 2y plus 2z equals negative 2. And now when I combine these, I've got 5x, 7y, the z's will cancel, and then 21 minus 2 is 19. So I've got an xy equation here and an xy equation here. So let's cancel out the x's. So I could do that by, say, multiplying this one right here by negative 5 and this one by 2. So I'm going to bring this down here and multiply by negative 5. So I've got negative 10x minus 15y equals 55. And then I'll bring this one down here and multiply by 2, and I've got positive 10x plus 14y equals 38. And my x's cancel. I get negative y equals, okay, so then I have 55 plus 38, so that's equals 93. Negative y equals 93, so y equals negative 93. And I know sometimes we get numbers like this, and we're like, oh, that's huge, that can't be right. But let's just hang on and see how it works out from here. Okay, so I'm going to take that negative 93 and substitute it into this original equation. So I've got 2 times 2x, I've got 2x plus 3 times negative 93 equals negative 11. Okay, so that's 2x minus, and then I've got 3 times negative 93 is 279, so minus 279 equals negative 11. Okay, then I'm going to bring this over, so I've got negative 11 plus 279, and that is 268. So 2x equals 268. And then divide by 2, and 268 divided by 2 is 134. So there's my value of x. Okay, now I can take that value of x and the value of y, and I think the easiest place to plug it in is right here. So I've got 134 minus negative 93 minus z equals 1. Okay, so 134 minus negative 93 is 227. So 227 minus z equals 1. Okay, and I will move the z over that way, the 1 over that way. So z equals 226. Okay, so let's see how well that worked. So 2 times x, 2 times 134, plus 3 times y, negative 93, equals negative 11. So first equation works. Sometimes it'll work in 1, but not all 3. Sometimes it could even work in 2, but not in all 3, which means we made a mistake somewhere. So 7 times 134 plus 5 times negative 93 minus 2 times 226 equals 21, just like it's supposed to. So it worked in the second equation. And then 134 minus negative 93 minus 226 equals 1. So that means our solution checks out. So 134 negative 93 226 is the correct solution. Okay, and our last equations, a set of equations, I think it's going to be kind of easy to cancel out these x's. So I'm going to take this one and bring it down here and multiply by 3 along the way. So I get 9x plus 6y minus 15z equals 36. Cancel, cancel, cancel. I get 0 equals 37, and I know that's not true. There is no solution, which means these are parallel lines. They never intersect.